In my last video on statistics, we have discussed variance and standard deviation and the formation of formula for variance and standard deviation. And we have also discussed some representative problems on variance with regard to discrete frequency distribution. In this part 2 of variance and standard deviation, we are going to discuss more problems on variance and standard deviation, and we will also discuss their significance. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. In continuous frequency distribution, the data is given in terms of classes with lower limit and upper limit, along with corresponding frequency of the class. In this case, we consider midpoint or class mark of the class as the representative of observation of the class, and then we calculate standard deviation according to the technique used for discrete frequency distribution. Let us see how. In continuous frequency distribution, the data is given in terms of class interval, say 30 to 40, 40 to 50, 50 to 60, etc., and the corresponding frequency Fi is given. For class interval 30 to 40, say the frequency is 3. For class interval 40 to 50, let it be 7. For 50 to 60, 12, etc. In this case, in order to get a representative value of each class, we take midpoints of each class, which we name xi, and they will be lower limit plus upper limit upon 2. In this case, it will be 30 plus 40 upon 2, 70 upon 2, 35. For class 40 to 50, it will be 40 plus 50 upon 2, 45. For class 50 to 60, it will be 50 plus 60 upon 2, 55, etc. Here, the values of xi, 35, 45, 55, etc. will act as discrete values for corresponding class intervals, and we will find mean x bar by the formula 1 upon n summation fi xi, the product of these two values, where n is summation frequency fi. After getting the value of mean, we calculate variance by the formula 1 upon n summation fi into these discrete values xi minus this mean value x bar whole square, and the standard deviation sigma as square root of 1 upon n summation fi into xi minus x bar whole square. Let us discuss all these things in detail. First, we will solve one problem in which discrete values xi and corresponding frequency fi are given. So the values of xi are 6, 10, 14, 18, 24, 28, 30, and corresponding frequency values are 2, 4, 7, 12, 8, 4, and 3. Our next column will be fi, xi, 6 2s are 12, 10 4s are 40, etc. 98, 216, 192, 112, 90. N or summation fi is 40 and summation fi xi is 760. At this stage, with the help of n and summation fi xi, we have to find mean x bar, which is 1 upon n summation fi xi. So it will be 760 upon 40, cancelling 0, x bar will be 19. Next column will be xi minus x bar. So 6 minus 19 minus 13, 10 minus 19, minus 9, minus 5, minus 1, 5, 9, 11. And the next column xi minus x bar whole square, that is minus 13 square, 169, minus 9 square, 81, etc. 25, 1, 25, 81 and 121. Let me write value of x bar 19 here, and final column is fi into xi minus x bar whole square, that is 2 multiplied by 169, 338, 4 multiplied by 81, 324, etc. 175, 12, 200, 324 and 363, and this summation is 1736. Now is the time for finding variance. Sigma square equals 1 upon n summation fi into xi minus x bar whole square. I goes from 1 to 7 because there are in all 7 observations. This is 1 upon 40 multiplied by this 1736, which will be 173.6 upon 4. So 4 ones are 4 fours are 16, 4 threes are 12, point 4 fours are 16. So variance sigma square is 43.4, and standard deviation sigma equals square root of 43.4, which is 6.59. Now we will understand another formula for finding standard deviation. In continuous frequency distribution, we find midpoint xi that has discrete frequency fi, and we use the formula for variance sigma square as 1 upon n summation fi into xi minus x bar whole square, which is 1 upon n summation fi into, we will expand this binomial square, xi square plus x bar square minus 2 times xi x bar equals 1 upon n into, now we will open the bracket, summation fi xi square plus summation x bar square fi minus summation 2x bar fi xi, that equals 1 upon n into summation fi xi square plus x bar square, which is a constant, summation fi minus 2x bar, which also is a constant, summation fi xi, which equals 1 upon n into summation fi xi square plus x bar square, and summation fi, as we know, is n minus 2x bar. Summation fi xi is n times x bar, because here x bar is 1 upon n summation fi xi, implies that summation fi xi will be n times x bar, which we have written here. This is 1 upon n into summation fi xi square plus x bar square into n minus, this is 2x bar square into n equals 1 upon n into summation fi xi square, this which is minus x bar square into n. By opening the bracket, this will be 1 upon n summation fi xi square minus x bar square after cancelling this n, which is 1 upon n summation fi xi square minus, for this x bar square we write summation fi xi upon n whole square. So sigma square is 1 upon n summation fi xi square minus 1 upon n square into summation fi xi whole square. Taking this 1 upon n square common, sigma square will be 1 upon n square into n summation fi xi square minus summation fi xi whole square, and standard deviation sigma will be 1 upon n square root n summation fi xi square minus summation fi xi whole square. So this is formula for variance and this for standard deviation. We have to find mean and standard deviation for the distribution given, where classes are 0 to 30, 30 to 60, etc., 180 to 210. Frequency values are 2, 3, 5, 10, 3, 5, 2. Summation of frequency n is 30. Since class intervals are given, we have to find midpoints, which is xi. It is 0 plus 30 upon 2, 15, 30 plus 60 upon 2, 45, etc. Next quantity that we need is fi xi. So 2 into 15, 30, 3 into 45, 135, etc. and 390. Summation fi xi is 3210. Next we shall need xi minus x bar. For that, at this stage we have to find mean x bar. So which is this summation fi xi 3210 upon n summation fi 30, cancelling 0, 3 ones are 3 ones are 30, 3 sevens are. So mean is 107. Next quantity that we need is xi minus x bar, which is 107 that we have just found out. So 15 minus 107 minus 92, 45 minus 107 minus 62, etc. and 88. We have x bar equals 107. Next quantity is xi minus x bar whole square. So minus 92 square 8464 minus 62 square 3844, etc. and this summation is 25228, and the final column is fi into xi minus x bar whole square. So 2 multiplied by 8464, 16928, 3 multiplied by 3844, 11532, etc. and 15488, and this summation is 68280. We have sigma square equals 1 upon n summation fi into xi minus x bar whole square, that equals 1 upon 30 multiplied by 68280, cancelling this 0, 3 ones are 3 twos are 3 twos are 6, 3 sevens are 21 and 3 sixes are 18, that is 2276. So here mean is 107 and variance 2276, and standard deviation sigma will be square root of 2276, 47.71. You will see there are a lot of calculations involved in this method. Let us see how to use another formula for finding standard deviation. That is, this formula, we are given discrete values of xi 92, 93, 97, etc. 109. Corresponding values of frequency are 3, 2, etc. and 3. Summation fi, that is n, is 22. Next we have to find fi xi. 92 multiplied by 3, 276, 93 into 2, 186, etc. and 327. This summation fi xi is 2200. Next we need xi square. So 92 square 8464, 93 square 8649, etc. and 11881, and summation xi square is 69227. Next we need fi xi square. So 3 into 8464, 25392, 2 into 8649, 17298, etc. and 35643, and summation Fixi square is 220,640. Now we have this formula for sigma 1 upon n square root n Fixi square minus summation Fixi whole square, that is sigma equals 1 upon 22 square root 22 multiply 640 minus 2200 whole square 1 upon 22 square root 14080, that gives standard deviation 5.39 and variance sigma square 29.02. You will see there are lot of calculations involved which get more and more complex, and the remedy for this is to use a shortcut method about which we are going to discuss now. We just saw that the calculation was huge and tedious, so we will study a different method called shortcut method to reduce the calculations drastically. This is a step deviation method in which we do not calculate the mean, but we assume it and call it assumed mean and denote it by A. We also need a quantity called class width h, which is difference between two successive values of xi. Now the step deviation denoted by yi is xi minus the assumed mean A upon the class width h, so that xi becomes A plus h times yi, and we name this 1. Next we have x bar equals 1 upon n summation fi xi. We name this 2. It is 1 upon n summation fi into, we replace this xi with this a plus hyi. This is 1 by n into opening the bracket a summation fi plus h summation fi yi, which is 1 upon n multiplied by a summation fi is n plus h into 1 upon n summation fi yi. This is cancelling this n, a plus h times 1 upon n summation fi yi is y bar. So we get x bar equals a plus h y bar, and we name this 3. Now variance of x sigma x square is 1 upon n summation xi minus x bar square, which is 1 upon n summation fi into, we replace this xi by this a plus hyi and this x bar by this a plus hy bar. So it is minus a minus hy bar whole square equals 1 upon n summation fi into a minus a is 0 hyi minus hy bar whole square equals 1 upon n summation fi. We take this h common and square it into yi minus y bar whole square equals h square into 1 upon n summation fi into yi minus y bar whole square. So sigma x square is h square, and this is variance for y sigma y square. Taking square root here, we get standard deviation sigma x equals h sigma y. Now from another formula for standard deviation, we have sigma y in terms of yi. So by using this, sigma x will be from this and this h upon n square root n summation fi yi square minus summation fi yi whole square. And squaring this, we get sigma x square variance as h square upon n square into n summation fi yi square minus summation fi yi whole square. Let us see how to use these two formulae to reduce the calculations. This 2 should be x and not 2. So this is sigma x square. Now we will see how this shortcut method can be used to find variance and standard deviation. For that, we will solve the same problem in which there were huge amount of calculations. The xi values are and the frequency values are. The first quantity that we need is step deviation yi, which is xi minus assumed mean upon h. The assumed mean will be somewhat middle value here 64 of xi values. So we have assumed mean 64 and h, as we know, is the difference between two successive values of xi, such as 61 minus 60 is 1, 62 minus 61 is 1, etc. So h here is 1. Now we find the step deviation values yi. The first will be 60 minus 64 upon 1 minus 4, 61 minus 64 upon 1 minus 3, etc. minus 2, minus 1, 0, 1, 2, 3 and 4. Here summation fi is 100. Next column is square of yi square. So minus 4 square, 16, minus 3 square, 9, etc. 4, 1, 0, 1, 4, 9 and 16. Next column is fiyi. So 2 into minus 4, minus 8, 1 into minus 3, etc. minus 24, minus 29, 0, 12, 20, 12 and 20. This summation is 0. And the final column that we need is fiyi square. So 2 multiplied by 16, 32, 1 multiplied by 9, 9, etc. 48, 29, 0, 12, 40, 36 and 80. Summation fiyi square is 286. First we will find mean x bar, which is a plus summation fiyi upon n, 64 plus 0 upon 100, 64. So mean is 64. Next let us find variance sigma square. It is according to this formula h square upon n square into n summation fiyi square minus summation fiyi whole square, which is 1 square is 1, n square is 100 square into 100 into summation fiyi square is 286 minus summation fiyi is 0, 0 square 0. This is 286 upon 100. So variance sigma square is 2.86 and standard deviation sigma square root of 2.86, 1.69. So we see that the calculations have been drastically reduced and we have been able to find the variance and standard deviation easily. Now we will solve the example which we have already solved, wherein lot of calculations were involved. Now we will solve the same problem by this shortcut method and will understand how the calculations are drastically reduced. Class intervals given are, corresponding frequencies are, sum of frequencies n is 30. Next we find midpoint xi, which is 0 plus 30 upon 2, 15, 10 plus 60 upon 2, 45, etc. and 195. Next we have to find step deviation yi, which is xi minus assumed mean a upon n. Now here assumed mean a is some middle value of x. We will choose 105 as assumed mean. So we have assumed mean 105. So accordingly 15 minus 105 is minus 90 and minus 90 upon 30 is minus 3. Next 45 minus 105 is minus 60. Minus 60 upon 30 minus 2 etc. minus 1 0 1 2 and 3. Next we need yi square, that will be minus 3 square 9 minus 2 square 4 1 0 1 4 9. Next we find fiyi, 2 into minus 3 minus 6, 3 into minus 2 minus 6 minus 5 0 3 10 and 6. Summation fiyi is 2 and final column that we need is fiyi square. So 2 multiplied by 9 18, 3 multiplied by 4 12 etc. 5 0 3 20 18 and summation fiyi square is 76. Now mean is x bar equals a plus summation fiyi upon n multiplied by h, which is class width, that is the difference between the higher limit and lower limit of each class. So 30 minus 0 is 30, 60 minus 30 is 30 etc. So h here is 30. Now we will substitute the values. A is 105 plus summation fiyi, which is 2 upon 30 multiplied by h, which is 30. So x bar will be 105 after cancelling this 30, 105 plus 2 107. Next we find variance. Now variance is according to this formula. It will be sigma square equals, after putting the values, h square, that is 30 square, upon n square, that is 30 square, into n, which is 30, multiplied by summation fiyi square, which is 76, minus summation fiyi whole square, that is 2 square. Cancelling 30 square, 30 into 76, 2280 minus 4 gives 2276. So this is variance 2276 and standard deviation sigma is square root of 2276, which is 47.71. So mean is 107 and standard deviation 47.71, which we have found by this shortcut method, and we can very well observe the amount of calculations that have been reduced. If you like this video, please like it, share it and subscribe to this channel. See you in the next video. Until then, keep watching Number Collage. Thank you.